Hello students, and welcome to the new module on sequential circuit design. In this module we are going to discuss the sequential circuits and system design. In this video we are going to talk about the sequential circuits, the level triggered circuit, and we are going to discuss a latch called SR latch. And then we are going to implement SR latch in Verilog. So let us get started. So as a revision, we had discussed that there are two types of circuits, combinational and sequential. When we talk about sequential circuits, these are the circuits that have memory element. That means they can keep a track of the previous output. They can store these values. These are the building blocks for any memory like random access memory, read-only memory, or we have different other memories in our system. So here the main concept is the concept of feedback. So we are going to take a portion of the output or the complete output as it is back to the input, and then in the next output calculation that value will be used. So sequential circuits are of two types. The first one is edge triggered and the second one is level triggered. What are these two types? Let us discuss them. So first of all, the triggering concept. Every sequential circuit requires an activation which is called triggering. Whenever we provide a trigger, then only this circuit will compute the output. This triggering is generally provided with the help of a clock. So here we have a square wave and this can be used as a triggering signal. Now, based on the type of triggering, we have level triggered and edge triggered circuits. Triggering is done with the help of clock signal, and we can trigger at the edge or the level of the clock. Now what is edge and what is level? Let us understand that as well. So first of all, we have this square wave. If I trigger my circuit at the level 1, that means when the value of clock is 1, I can call it that my circuit is positive level triggered. We can also trigger or calculate the output when the value of clock is 0, and these circuits are called negative level triggered. Now, instead of calculating the output at the level 0 or 1, we can also calculate at the edges when the values are changing from 0 to 1 or 1 to 0. If we are triggering at the rising edge, that means we are going from 0 to 1, it is called positive edge triggered. And if we are triggering at the negative edge, that means when the value is shifting from 1 to 0, then the circuits are called negative edge triggered circuits. So now let us take the first sequential circuit into the consideration. We have SR latch. A latch is something that can hold the data. Typically it is 1 bit, and we can keep storing the data or we can update it. So in the set reset, that means SR latch, we can continue holding 1 bit of data until we set or reset the value of the stored data. We set the latch by putting the data value as 1, and we reset the latch by putting the value as 0. In hold condition, the value will be maintained. So whatever is stored, the same value will remain. Now let us have a look at the truth table of SR latch. We have two inputs S and R, and we have one output Q. When S is 0 and R is 1, we are allocating our output value to 0. When S is 1 and R is 0, we are allocating our output Q as 1. Now the hold condition is when S and R both are 0, 0. In that case, whatever is the earlier value of Q, the same will be retained. We do not provide 1, 1 as our input. This creates a lot of problem and it will give you the invalid output. So we should never give 1, 1 as input to SR latch. Now, how do we construct one SR latch? So we can construct it using two NOR gates. One of the NOR gate is having S as input, one of the NOR gate is having R as input. The output of NOR gates are cross coupled as input to the other NOR gate. So here we are using two NOR gates, and it can also be designed using NAND gates. Sometimes SR latch can be designed by having additional enable signal as well. So all these possibilities are there in the circuit implementation. The circuit that we have here is the simplest and the first version of implementation of an SR latch. Now let us go to Vivado and implement this SR latch in Verilog. So we are back in the same project, and now we are going to create a source and we call it SR latch, and then we are going to define 4 ports. One is S, one is R. These two are the inputs. Q and Q bar, these two are the outputs. So now we have defined the ports and we are going to start the coding part. Now let us start the coding. So the coding will be done in gate level modeling, and we say NOR. We have seen the circuit diagram that Q bar and R, they will be connected as input to one NOR gate and the output will be Q. Second NOR gate is going to have output as Q bar and the inputs are Q and S. This is the simple program. We save it and make sure that your program is set as top module in design sources as well as the simulation sources. Once this is done, you can generate the schematic now. As we observe the schematic, we can see S and Q, they are generating Q bar. Q bar and R, they are generating Q. Now let us cross check the functionality using the simulation. So we run the behavior simulation now. The simulation environment is ready. So we are going to set S as a clock from 0 to 1 with a time period of 100 nanosecond. For R, I am not going to keep the same time period. I will keep it as a non-multiple of 100, not a multiple of 100, so that we can have unsynchronized clocks. So something like 170, 180, 220, and then we run for 800 nanosecond, and here we look at the results. So now you can see when it is 0, 0, initially nothing was there, so it is X. 1, 0, S is 1, Q is 1. 0, 1, S is 0, so Q is 0. After that, when we get 1, 1 case, here Q is 0, Q bar is 0, but Q and Q bar should always be complementary to each other, and that is the reason we never take 1, 1 case. Now here I have 1, 0, so Q is 1, and 0, 0, the same value of Q is preserved here, and you can observe it in all other cases as well. Here S is 1, R is 0, so S is 1, and in the 0 0 case again the value of Q is preserved. So students, now we have discussed about SR latch, which is basically a level triggered circuit. In the next video, we are going to talk about flip-flop, which is edge triggered circuit. So same functionality but a different triggering. Keep learning. Thank you.